Okay, we're going to go over the solutions for homework 5. I'm in the directory, I've already checked it out. So let's go ahead and start on problem 1. I'm going to open up po1.c in my favorite editor. And in this problem, we are supposed to fill in the function count1, which will be in here. It takes an unsigned int x as an argument. We're supposed to count the number of ones in the binary representation of x and return the corresponding unsigned int that has the same number of ones in its most significant bits. Alright, so I'm going to start out with an unsigned int. I'm going to call it y, and I'm going to set it equal to 0. Alright, and that is the number that we're going to return. Return y. So somewhere in the middle, we need to put the ones in the significant bits of y. Alright, so I'm going to, let's first set up the for loop that is going to, I'm going to have a mask for x. So I'm going to have an unsigned int mx for, it's the x mask. I'm going to also have a mask for the y variable. But I'm going to start out with this one. So I'm going to start it out at 1. And I'm going to continue the loop while mx is not equal 0. And then I'm going to, on the increment step, I'm going to left shift it by 1. Alright. So that starts mx with a 1 in its least significant bit. And this loop will continue until we left shift by 1 each time until it becomes 0. Alright. So we'll have a 1 in each index for the unsigned int binary representation. Alright, so I need to do the get operation that we discussed in class. I need to use my mask to see if there is a 1 in x in the binary representation at this index. So I'm going to say if mx and x. Alright, so if there's a 1 here, mx and x is going to return a number. It's actually going to be a power of 2. It's not, this won't work. You can't check to see if it's actually 1. It's not going to return a 1. It's going to, this expression, mx and x, will evaluate as a number from, as a power of 2, not as 1. Sometimes it'll be 1, but not always. So, and recall any number besides 0 is true in C. So if there's a 0 there, mx and x is going to be 0, because the AND operation when you have a 0 and a 1 is 0, which will make it false. Alright. So I need to do something in here if I find a 1. One solution is to keep a count of all the 1s and then do something to y after this loop, but I'm going to edit y here. Alright. So to do that, I'm going to need one more unsigned int, and this is going to be my y mask. Alright, I want to start this mask with its 1 in the most significant bit. So I need to start that at 1, left shifted by the size of an unsigned int multiplied by 8. And then I'm going to subtract 1 from that. That way the 1 doesn't fall off on the end. Alright, so now that's a 1 in the in index 31 of the binary representation. So I started out there. Now I can set, if I find a 1, I can now set a 1 in the significant bits of the y variable. So I'm going to say y is going to or equal my. Alright, so oring them together is going to set that bit. I'm doing the set operation here. So this right here is the get operation, and this right here is the set operation. Alright. I'm going to say y. Now I need to move the 1 in my mask over by 1. My right shift equals 1. Alright. That actually is good for problem 1. That is a complete solution, I believe. So let's go ahead and save that. I'm going to run make. Alright. It tried to make everything. Alright, it did make everything. So now I'm going to run the homework check on this assignment. So I need to say, I'm going to change directories to the directory that contains my homework 5 directory. and I'm going to run the command handin -c cs202. I have to do that because I am in my Gaulish account, not a 202 account. And I'm going to do --hw check and homework 5. I passed 3 out of 3 checks for problem 1. Alright, let's move on to problem 2. I'm going to close that one. I'm going to go into homework 5 one more time. Let's open up problem 2.c. Alright, for this one, we have 2 functions to fill in. These are pretty simple. This is the set and clear operation that we talked about in class. So this one should set the bit at index I, and this one should clear the bit at index I. So let's do set first. Set, we just did that, technically, in the first problem, although we didn't have its own function for that. So to set, we're going to use the bitwise OR operator. Alright, so I just need to return, and I'm going to return x, I'm going to put this in parentheses, x, or, and now I need to put my mask in parentheses right here. So my mask is going to be 1 left shifted by I. Alright, that's pretty cool. If I was being really careful, I could have some error checking here to make sure that the index isn't too big for the type for an unsigned char, but I'm not too worried about that right now. That's not part of the example inputs for the homework check, so I'm just going to leave it like this. So that should work for setting the bit. So now let's go and look at clearing. There's 2 choices that we talked about in class. We can use XOR, and if we use XOR, we have to check to see if the 1s are already there. Remember, if a 0 is already there. So if there's a 0 there, using XOR will set a 1 there, unless so I don't want to use XOR if there's already a 0 there. Alright, so that would require me to use get and then set, right? And then XOR. So instead, I'm going to do the other way that we talked about, which was we AND the mask, but first we not the mask. So it's like an AND not operation. So I'm going to return x, and so now what I need to do is I need to make a mask with all 1s except a 0 in the index. Alright, so to do that, I'm going to still do 1 left shifted by I, but I'm going to put a tilde on the outside, which is the not operator in C. Alright, so that flips the bits of the mask, and that's the clear operation. So we just did both those in one line. I'm going to save it. Let's call the homework check one more time. And oh, look at that. Only passed 1 out of 3 checks for problem 2. Okay, so what happened was I was getting an incorrect reading. Okay, I forgot to rerun make before I did the homework check. So I ran make and I did the homework check again, and then I passed 3 out of 3 checks. So you have to remember, homework check doesn't run make for you. You have to run make. All right, that was the only problem. So I'm going to go back in homework 5. This was indeed the solution to homework 2. Problem 2. All right, so let's go ahead and do problem 3. Vim po3.c. In this one, we are supposed to fill in the function I to bin. It takes an integer and a string buffer as arguments. We are to convert the integer to binary, placing the binary string in buffer. Assume that buffer has already been allocated and in an appropriate amount of memory to hold 32 bits. All right, and a reminder, it'll be your job to place the null byte in the appropriate place. Returns the buffer. Okay. So in this problem, buffer has already been allocated for us. We know it has enough size, or we hope that it has enough size, and we just need to put the binary representation of x in the buffer. All right, that's already an array and we just have to put the string in, and then we need to put the null byte at the end. All right. So the first thing that I want to do is I'm going to make a mask. We need that same for loop that we had before. For unsigned. By the way, if you don't want to type in unsigned int a million times, let's go up to the top. And I'm going to make, for this one problem, I might do this in the other ones too, type def unsigned int, and now I'm going to call this a uint, uint underscore t. Okay, that'll let me type in uint underscore t rather than unsigned int every time. So I'm going to say uint underscore t, m for mask. I'm going to set it equal to. Okay, I want it to start. Let's do this in a different way. Let's do it with a while loop this time. We did it with a for loop last time. So I need a uint underscore t m. I want it to start all the way to the left. All right. So in the most significant bit. So I'm going to set it equal to 1 left shifted, the same thing we did before. Size of the uint underscore t times 8 minus 1. All right, so that's something that you will do often whenever you're working with bits, so something you can remember. All right, we don't even need to mess with bits here. One thing you could do is you could do the divide by 2, mod by 2 algorithm we talked about in class that converts the integer to binary. It works for any base, really, but we want to use bit shifting for this one. It's actually, a little bit easier just to look at the bits because remember, all numbers, all variables, they're all stored as binary in the C program. We think of them as decimal or hexadecimal or octal, but they're all stored as binary already. So we don't need to convert it. So I start my mask out with the one in the most significant bit. I'm going to have a while loop, while m, so while it does not equal 0. I'm going to, the increment step will be m, right shift equals 1. Alright, so here's where I need to put my code. If, I need to do the get operation, again, if m and x. That's the get operation. So if there's a 1 there, alright, so what we can do is, if there's a 1, we want to put a 1 in our buffer, and if there is not a 1, we want to put a 0 in our buffer. Alright, so we're going to need to keep track of the length of our buffer. Alright, so I'm going to start it out at 0. I'm going to say buffer length plus plus equals a 1. Alright, and I'm going to do buffer length plus plus equals a 0 in the else block. Alright, so that's actually the entire chunk of code there. At the very end of our while loop, we're going to want to put a null byte at the end. So that's going to be buffer length equals the null byte. Alright, so the reason why I have length plus plus here and not in these two, and this in line 30 and line 32, and not on line 37 is because it matters about incrementing the length in this line and this line. But here I'm done, right? So I could increment the length, but it's not really necessary. Then I return a pointer to buffer. All right. It's not necessary to return the length of the string either because putting the null byte at the end automatically makes it a string and it'll work with printf and string length and all of those functions. All right. That's the point of the null byte. All right. So yeah, this one's done. Here's an alternate version. If I were to say comment out these, I could do this in one line with the ternary operator, which is kind of cool. So I could say buffer, oh, can't type, buffer length plus plus equals, and now I could do the ternary operator here. I could say m and x question mark, and then I would put a 1 here, and a colon, and a 0 here. Alright, so this is the same thing as this if-else statement, but in one line. So this would work too. But, so I'm going to comment this one out and uncomment these ones. Alright, we're going to use this version. But that's an alternate way of doing it that I kind of like. So let's go ahead and save this one. And we will rerun the hand-in command one more time. Alright. Oh, look at that. I forgot to make it again. So if I want to make it from this directory rather than homework 5, I'm going to go make -c hw5. So that'll change the directory to homework 5 before it runs make. Alright, so we just compiled problem 3 for me. Now I can run hand in one more time, and I pass 3 out of 3 checks. So that one is complete. Let's go back into homework 5. I'm going to close out of that one. We're going to open up problem 4. All right. This one, we need to fill in the swap bytes function. This takes an unsigned short of the parameter. We're going to swap the 2 bytes in x using bit operations, and we're going to return the result. All right. So we know an unsigned short is 2 bytes on our system, which is 16 bits. All right. So this one might have given a lot of you trouble, but this one actually has a one-line solution that's really nice. All right. So I can do return. So the idea is I want to take, so let's do an example right here. So if my unsigned short has 16 bits, what I can do is, it's like, it'll be like, 0, 1, 1, 0, whatever, 1, 2, 3, 4, 5, 6, 7, 8, and then these will be, okay, so there's my 16 bits for my unsigned short. What I can do is, I can left shift by 8, and then I have 0, 1, 0, 0, 1, 1, 1, 0, like this. And I can also right shift by 8, where I get 1, 1, 1, 1, 0, 1, 0, 1, and all zeros right here. All right, and then I can treat this like a math problem, and I can OR them together. All right, so this is my math problem, and if I OR these together, I get 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0. There we go. So that's the idea. So the bits are swapped. Say this is x. Okay. So I'm just going to implement that in code. I need to close off the comment. All right. Return. I'm going to return x right shifted by 8 or x left shifted by 8. All right. I'm going to put that in extra parentheses there for the OR operator. All right. That's actually the entire solution. So yeah, that's pretty cool, right? So let's go ahead and try it. We're going to make before we go to do the hand-in check. And I'm going to run the hand-in check one more time. I passed 3 out of 3 checks. So that one's actually a lot simpler than you might have thought initially. So let's go back into homework 5. And I'm going to close out of that one. Let's open up problem 5.c. Okay, let's do number 5 now. For this problem, we need to fill in the print base formula function. And what it does is it takes in some integer x and some base between 1 and 16. And we are in charge of printing out the place value representation of that number in that base. So if x is 25 and the base is 10, it should print out 5 times 1 plus 2 times 10. All right. So if the base is greater than 10, like 11 through 16, I don't want to print out so for the number 15, I don't want to print out 15 times 1. I want to print out f times 1, right? That's how hexadecimal does it. That's how bases greater than 10 should work. So the first thing I'm going to do is I'm going to make a char key. Okay, so this is going to be my key, and I'm going to set it equal to a string 0 through 9, A, B, C, D, E, F. So I'm going to use this string simply to convert my my place value, the numbers that are in the place value, to a letter if it's greater than 10. That's really all it's for. All right. Okay, so I'm going to use the algorithm that we talked about in class, where we take the number, when we're converting it to another base, we're going to divide it by the number to... First, we're going to mod it to extract the current place value, and then we're going to divide it to remove that place value. All right, and that's going to be integer division, which is mathed out floor, essentially. We're taking the floor of the division. So I'm going to have a while loop. If we keep doing integer division on x, eventually it will become 0. So I need a while loop while x is not 0. Okay, that's going to be my condition for breaking. And in that while loop, at the end of the while loop, we're going to divide it by the base. Okay, and let's go ahead, let's try to print out 5 and 2 first. Okay, the place values. So we're just going to try and print out the place values first. %d, let's put spaces between them. We get the place value by saying x mod the base. Alright, we're going to need to put a printf at the bottom of the while loop and put a new line in there. That's just going to clean up the output. I'm going to run make, and I'm going to run problem 5. Let's put in 25. There we go. So we got the place values correct. Let's do it again, but let's do 15 this time. Notice for the hexadecimal, we got 15 rather than f. Okay, and if you look here, f is index 15 in our key. That's because x mod base is actually the key, the index. It tells us the index for our key. Alright, so I want to say key sub x mod base. So I want to use that as the index for my key. And that makes me have to change this to a %c. Alright, so let's recompile and rerun it. And put in 15. There we go. I got f as my place value, as the number that was in that place value. Okay. So the next step is we want to have this number here, the number that we're multiplying it by, which is the place value in that case. So I'm going to start my place value where it will for all of the bases at 1. Okay. So the place value starts at 1. And each time through, at the end of the loop, we need to multiply the place value by the base. Okay. Now I can edit my format string and add in the times, %d space plus space, and I'm going to pass in the place value. Okay. Run make. There we go. Put in the 15, and look at that. That's good. The only problem now is I have these annoying plus signs in the end. We got to get rid of those. Okay. So notice that the plus signs shouldn't be there when x is less than or equal to, no, when x is less than the base. So if x is less than the base, there shouldn't be a plus sign there. So let's go ahead and do that. I'm going to use the ternary operator inside the printf statement. So I want to say if x is greater than or equal to the base. If that's the case, then I want this to be my format specifier. Otherwise, I want simply %c space %d to be my format specifier. Okay? So that's just a ternary operator inside. So the whole ternary operator will be evaluated before printf gets its parameters. So if x is greater than the base, this will be the parameter to printf. Otherwise, this will be the parameter to printf. So that's how that works. All right. So let's go ahead and save that. Make ./po5. Let's pass in 25 again, and there we go. Let's try like 100. Okay, that got rid of the plus signs on the end. Now here, this actually brings up another problem. 0 times 1 is in here. 0 times 2. Those aren't really necessary to show. Okay. We just want our. Hold on, we got some issue here. I just noticed. Oh, I know what's wrong. Okay. In here, I should have. It still needs the time symbol in the middle. Okay. What did I do? There we go. We still need to put that time symbol here. There we go. We're gonna make again and run. Pass in 100. There we go. That fixed the output. That looked weird. Okay. So now we need to get rid of these 0 times the place values. We don't want those in there. It'll clean up the output a little bit because they're not necessary to tell us the value of the number, right? So what we want to do is we only want to do this print statement if x mod base does not equal 0. Okay, so it's that simple. I'm just going to go above if x mod base does not equal 0 and indent that. There we go. That should fix that problem. Let's make problem 5. We're going to run it. We'll pass in 100. There we go. Now I just have the necessary place value representation. So let's check my work here, hand in. I'm going to, oh, there we go. We passed 3 out of 3 checks. So